Alrighty, we're going to continue on with learning about naming ions and practicing a few examples. Before we can really get into naming both cations and anions, we want to make sure that we are confident in naming each of them individually. So when we talk about chemical bonds, there are two types. There's ionic and there's covalent. Ionic involves a metal with a nonmetal. So we're going to practice naming the metal first and then the nonmetal second. But we're going to separate them so that we can be confident in that, as we said before. When you have an ionic bond, of course, that metal and nonmetal combine together and, in essence, complete me. I know, bad chemistry jokes. So let's take a look at our individual ion charges. You'll notice in red we have all of our positive or cation charges. In blue we have our negative or anion or a negative ion charges. And then in green we have our noble gases, which have a charge of 0. Our goal, of course, is to achieve a full octet or 8 valence electrons in the outermost energy level. Group 1 has 1 valence electron, so we lose that 1 valence electron to drop down an energy level to get to 8. Our group 2 has 2 extra electrons, those 2 valence electrons. It loses those 2 to get a positive 2 charge, and now we have a full octet. The same goes on for all of our others. You'll notice as we move to the right of the periodic table, our halogens, for example, have 7 valence electrons. A full octet would require them to earn 1 more, which is why they gain that -1 charge. So let's look at a few examples together. Here are just our cation charges, as we talked about before, +1, +2, +3. And let's take a look at just our examples here. So if I take a look at the magnesium ion, we want to determine what the magnesium ion charge is going to be. Using my periodic table, I identify where magnesium is, which is right here, atomic number 12, and then I can determine its corresponding charge. So we see that magnesium has a +2 charge, and it's written actually Mg2+, but even if you write Mg+2, that's fine. Looking at a second example, what is the charge on the boron ion? So we identify where boron is. It's a B, element number 5 on the periodic table. Boron has a 3+ or a +3 charge based upon where its location is on the periodic table. Now, when we get into the middle part, which we call our transition metals, and this is this section and a few of them underneath the staircase as well, those charges can vary quite considerably, and they can have more than one possible charge. So we need to be very specific when we identify what the charge is. So you're going to be given some information to determine that. And so the way we're going to look at that is, or identify that, is going to be based upon Roman numerals. So if you have a +1 charge, we're going to specify that with Roman numeral 1. If, for example, you have a +5 charge, we're going to specify that with the Roman numeral V, and so on and so forth. Again, these are all cations, so they're always going to be positively charged. So you don't need to specify positive or negative with the Roman numeral. If you see a Roman numeral, it's positive because these are always for metals, and metals always have a positive charge. They always lose electrons to achieve their full octet. Looking to the next example here, what is the symbol for an iron II or iron 2 ion? So the way that we would represent this is we look at our iron here, and we see that it's got a Roman numeral 2. So I know that iron has a +2 or an Fe2+ representation. If I look at manganese 7+, I would represent that by what Roman numeral? Thinking about our chart, I would say manganese, and then I would put in Roman numerals VII, which is the Roman numeral 7. Next, we're going to look at our anion charges. As a reminder, anion, you can remember it as a negative ion. So our anions on the periodic table are our nonmetals. So we're looking at carbon and silicon, nitrogen and this set of family, oxygen and its family, and then our halogens. Remember, everyone's trying to get to a full octet, so we want to get to 8 electrons. So for example, if I'm the halogen group, I already have 7 valence electrons. 1 more, or a -1 charge, will get me to 8 valence electrons and to be very stable. So let's take a look at how we would actually name the anions. If I'm looking at the phosphorus ion, remember that I want to change my name to end in IDE and then represent the charge here. So the phosphorus ion would have a name of phosphide. Again, IDE, it's just written nice and big to remind us to add that IDE ending from the phosphorus piece. We're going to change that component. Finally, the charge for the phosphide ion then would be based upon which family it's in. And so nitrogen in its family has a -3 charge. So my answer is P3 minus. Next one, the name of the iodine ion. Remember, we changed the name. So iodine becomes iodide, IDE, and it is a halogen. So our final answer then would be I with a -1 charge. The 1 is understood. You don't have to write that, though you certainly can. Next thing we're going to look at is a chart with polyatomic ions. These atoms are not on the periodic table because they are composed of 2 or more atoms. So for example, you can see a list of the most common polyatomic ions that you'll see in general chemistry. For example, we have acetate, nitrate, cyanide, hydroxide, and so on and so forth. The only one that has a positive charge is ammonium, but the rest are all negatively charged. You can see their charges that are up here in the superscript position. So nitrate, for example, has a nitrogen and 3 oxygens, and the total piece here contains a -1 ion. The nice thing about these is they're written exactly as they are in the chart, and the names are read exactly the same. So you don't have to change the endings like we do if we have our anions. Acetate is always acetate, nitrate is always nitrate, for example. So let's practice. What is the name of ClO3 minus? So I'm going to look for where this is in the chart, and I see that ClO3 minus corresponds to chlorate. What is the name of SO4 2 minus? I'm going to look at this reference chart, which of course you'll always have on your quizzes and tests. I locate that on the chart, and it is the sulfate ion. So again, polyatomic ions can be positive or negative. Most of them are negative, and you write their names exactly as they're written in our chart. Our next class will be looking at combining both the cations and the anions to produce a neutral compound. And that's it for our lesson today. Chemistry Cat believes in you. Keep on practicing.